Hi, welcome to the course on deep learning. In this lecture, I will be talking about convolution neural net (CNN). So, convolution neural net was developed in 1990s, but it really got noticed after 2012 when researchers started winning various competitions like ImageNet, in which we have to classify an image in 1000 classes. So they were getting very good results after using this algorithm. So people really got interested in this algorithm and started using it in various applications. Uh, and right now, CNN is used in almost every computer vision task that you know of. For example, classification, like classifying an image of a cat or a dog, and in object detection by a self-driving car to detect a, another car, pedestrian, or a motorcycle. In image captioning is in which we have to uh, generate text description of an image. In all these tasks, CNN is widely used and really giving very good results. So to understand it, let's first talk about classification. So in classification is to classify an image into certain classes. For example, if we want to classify an image in two classes, cat and non-cat, so there are two classes in which we have to classify our image. So in this in the whole model, we will provide an image in an CNN architecture. Let's call it a box for now. So we give this box an input image, and it will give an output to classify that image. So so a good model should classify an input image correctly, a cat or a non-cat in our example. So to to make this box classify our image correctly, we have to train it so that it can learn how a cat looks like. So consider this box like a child. So to train a child, we have to make it learn by giving examples. And in this case, we will uh, train our box on a labeled data set. It is a supervised learning in which our data is labeled. So our data is image. So for example, our data set consists of 10,000 images, in which 4,000 images are of cat and remaining 6,000 are of non-cat. So we train this box on this data set, and this box will learn by these examples how a cat looks like. So after training, uh, if we give this box input an image of a cat outside this training set, it should classify it correctly. So so now what is inside this box? This box has CNN architecture. So CNN architecture consists of various layers of CNN. It can be of various size. To understand the whole architecture, first we have to look on a single layer. So a single layer, and to understand the single layer, first we have to know what is an image. So an image is a matrix, of pixel values. You must have heard about 5 megapixel image, 4 megapixel image. So these are all values. So for example, this is an image of 6 by 6 pixels, and 1 represents the channel. So there's a one channel, so it's a grayscale image. If there are more three channels, if the image is colored, then it has three channels, RGB, like this. So what we do is we convolve it within another matrix of some size, of small size. In this example, let's take a 2 by 2 matrix, a small matrix with one channel. So this channel should be same as of image in which this matrix is convolving. So we are convolving these two matrices. So what convolving means is to multiply and slide. So we take this matrix and we multiply it with the space of 2 by 2 in this matrix, in this image matrix, and after that we slide and we multiply with this space, and again we slide and multiply with this space, and so on, and we slide down, multiply it, slide and multiply. So this, after doing this convolution, we will get an input of a matrix, and that matrix size can be calculated by a formula n minus f plus 1. So n is the size of the input image, f is the size of a filter. So in our example, 6 minus 2 plus 1, 5. So 5 will be the size, I mean 5 by 5 by 1 will be the size of the output image. Now what we do, we add a bias in this matrix, and we apply a function called relu, which give non-linearity to the matrix. So it can also be interpreted as y equals to mx plus c, in which x is our image, m is a filter, we convolve them and we add a bias, and additional we apply a relu which give it non-linearity. So this does not change the size of the matrix, so our output will be 5 by 5 by 1, because we are using one filter. If we are using two filter, we will get two matrix of same size, 5 by 5 by 1. And if we are using 10 filters, we will get output of 10 different matrix of same size. Now what it does, it combines all those filters. Like if we are using two filters, it will combine them to give a final output as 5 by 5 by 2, and if we are using 10 filters, it will give output of final 5 by 5 by 10. So this number of filters is of our choice, we can choose any filter number of filters. So this is a single layer of convolution. So the output of this first layer will be the input of second layer, and again we will use some size of filter and of same channel as of previous input, and we convolve them, add some bias, apply relu, and we'll get some another output. So this will continue for the layers, for as many layers we want, and this will be the whole convolution architecture. So the final output we get by applying a function called softmax. So that softmax function provides the probability. So for example, if we are giving an image in this architecture, the output will be a probability of, so probability will be how much that architecture think that the input image is of certain class. So from that probability we update the parameters of the architecture. So, and these parameters are nothing but weights and bias terms. So what are weights? Weights are the values of this filter matrix. These are all weights. These all get updated by the result of the by the output of the architecture, and this is how it learns. If it gives bad result, it updates the weight values to give better results. So this is how architecture is trained. This also consists of more complexity, for example, strides, padding, max pool layer, fully connected layers, and all this comprises of a single architecture. There are many architectures which researcher have already made and tuned. So these are all really difficult to tune to get a good result. So, but there are many architectures available. For example, AlexNet, ResNet, InceptionNet, GoogleNet. So these are all architecture which you can use in your applications. So that's all. Hope you enjoyed it. Thank you.